How on earth does rotation in the outer space levels, how can that be the greatest cause of the enormous redshifts of galaxies in deep space? Apart from my interest in science, as a youngster, when I was discovering the Urantia book, I very quickly realized that the important thing, the main thing, is falling in love with the divine lover incarnate in our soul. Of course, that leads to that life of loving service. So that's sort of the background. From there, I then dived into my scientific sort of endeavors. And over the years, certain of the scientific statements have stuck in my mind. For example, that line in 12.4.15 about how the greatest cause of the distortion or redshifting of spectral lines is rotation. How on earth does rotation in the outer space levels, how can that be the greatest cause of the enormous redshifts of galaxies in deep space? This was a niggling enigma in the back of my mind for many years. And well, here we are. This is what we'll explore today. And also, if anyone notices anything which is inconsistent with the Urantia book, please make a note and let me know. My main focus here is to use very literal reading of the Urantia book and synchronize that with astronomical discoveries. And enjoy the movie. In 2014, astronomer Brent Tully and his group presented this model of a local cosmic flow. This was their attempt to map the distribution and motion of all the energy, mass and matter within our local supercluster of galaxies, so-called Laniakea. Now, within this local region of space, astronomers have a number of techniques for measuring distance and for proving that this local bubble of space is expanding. However, as we probe deeper into space, native cosmology increasingly depends not on actual measurements of distance, but on assumptions about redshift. Regarding redshift, the Urantia book makes an extraordinary claim that the enormous redshifts of galaxies in deep space are due not to a runaway expansion, but to a number of causes, the greatest of which is rotation. By combining a system of rotations with an expansion and contraction of all space, these papers provide a fresh explanation for the pattern of redshifts we observe. And in the same way that Kepler's simple insight changed our model for the solar system, these fresh ideas about redshift imply a remarkable new model for cosmology. But how on earth do you get redshift from rotation? Well, as we'll see, getting cosmological redshift from rotation is surprisingly simple. But before we get to that, we should keep in mind something a famous physicist, Richard Feynman, once famously said. To paraphrase, if your beautiful theory or model does not fit the data, then it's wrong. Since a Urantia book model is so unorthodox and vast, before we try to use this model to explain redshift, we should check how it lines up with some basic facts of science. To help set the stage, we'll begin by reviewing some fundamentals. First, those standard models of physics and cosmology. Next, we'll check what astronomy reveals about our region of space. Then we'll compare all this with those outer space levels the Urantia book describes, which will bring us to the redshifting of light and the effect of relativistic rotation. Finally, we'll collect some final thoughts about what we find. If time allows, I have added, as appendices, a few highlights worth exploring more deeply. Okay, let's begin. A century of progress in both cosmology and particle physics has left us with certain mysteries and tensions in current standard models. At the largest cosmological scale, astronomy reveals apparently mature galaxies existing at what was thought to be the dawn of time. At the smallest quantum scale, well, many questions remain. Safe to say, at the cutting edge, scientists might feel increasingly justified in questioning certain assumptions about what we thought we knew. For students of the Urantia Book, this current curiosity about truly fundamental things raises the question, can the Urantia Book help to solve these mysteries and resolve these tensions? Well, let's set the stage. Between about 1910 and 1930, a few bright minds were formulating ideas about two deep mysteries confronting the science of the day. One of these mysteries involved the quantization and interaction of energy and mass. The other involved cosmology, the distribution and motion of energy, mass, and matter throughout the universe. By 1933, foundations for particle physics and cosmology were taking shape, and the almost inevitable trajectory of both had become predictable. Particle physics would get lost in quantum fields, while cosmologists would feel compelled to assume some sort of Big Bang origin for the universe. So in 1935, in the spirit of, quote, authoritative elimination of error, the authors of the Urantia papers revealed very different foundations for both. Their foundations for cosmology are what we'll explore today. But since these foundations depend on energy, mass, and matter, that is to say, particle physics, we should spend a few minutes reviewing what these papers say that energy, mass, and matter actually are. Let's start with what we know. Native science has built up a compelling tale about how galaxies and stars are built up from clusters of atoms, and how atoms are built from clusters of leptons and quarks. Currently, these leptons and quarks are thought to be elementary, that is to say, not made from smaller parts. This scheme, based on the interaction of leptons and quarks, is called the Standard Model of Particle Physics, and it describes most things we see really well. But in particle physics, this model is thought of as an effective low-energy approximation, which implies another high-energy domain, which is where the Urantia Book comes in. The Urantia Book approaches this standard model from the other high-energy side, introducing these ancestral levels of not quite finite stuff. In the middle here, between what we can measure and what's been revealed, we have a region of interest. It's interesting to scientists. They want to know more about leptons and quarks. It's interesting to students of the Urantia Book for reasons we're about to see. Regarding this standard model, two things are missing from this picture. First, Planck's quantum of angular momentum, and what we call a Higgs-type field. What if we put these two together, this condensate of charge and this quantum of angular momentum? Well, given the way that angular momentum in a superfluid tends to quantize, a quantum of angular momentum acting in this superfluid condensate of charge implies a vortex, the very tip of which becomes a point-like thing, a spinning, irreducible quantum of ultimate energy density, the ultimaton. And since this ultimaton is literally the ultimate uncuttable thing, the ultimate atom, this name, ultimaton, is certainly appropriate. Now, for the experts, notice a connection between space potency and ultimatons. Since space potency is also called absoluta, we can make a case for this ultimaton being a quantum of paradise absolutum. More on this in Appendices 3 and 6. Meanwhile, that famous but unexplained huddling proclivity of ultimatons allows tiny clusters naturally to form. And from such clusters of huddling ultimatons, we get these neutrino-like things, tiny building blocks for standard models, leptons and quarks, all spinning in a background field of primitive force charge, that standard model Higgs-type field. Now, if we simply identify this standard model field of primitive, primordial, weak hypercharge with the Urantia Book's primordial force charge, we solve a few deep mysteries of particle physics. In standard model terms, what we have here are structures of quantized weak hypercharge, acquiring inertial mass and electromagnetic charge by interacting with that condensative charge, the very stuff from which ultimatons are made. That's a quick review of energy, mass and matter from a Planck scale view. For those who'd like a closer look at all this, we go into more detail in those previous parts. Okay, let's now shift to a more astronomic or cosmological perspective. In the Urantia Book, the prehistory of a spiral galaxy begins when a primary force organizer interacts with absoluta, condensing a halo of segregata. An associate force organizer then spins up this superfluid stuff, some of which begins to quantize as ultimatons. Some of those ultimatons then begin to cluster, as we just saw, becoming standard model atoms built up from leptons and quarks. However, being pre-electronic, neither segregata nor ultimata interact with electromagnetic light. So both this halo of segregata and this disk of ultimata are invisible or dark. Notice what's just happened. By describing such foundations for galaxies, the Urantia Book has revealed two distinct sources of invisible gravitational effect, what astronomers currently call dark matter. Here, recall that in paper 4229, segregata is also called, quote, pure energy. So, following Einstein, if we divide all that energy by the speed of light squared, then we get an awful lot of mass, or rather a whole lot of invisible gravitational effect. Meanwhile, 3 paragraphs later in paper 42.212, ultimatons are described as, quote, the first measurable form of energy. In Appendix 3, we say a little more about why ultimatons turn out to be the ultimate, so-called WIMP, a second source of invisible gravitational effect. What makes this interesting is that by 1935, 2 years after Fritz Zwicky first noticed the need for invisible mass, 40 years before, Vera Rubin measured those flat rotation curves of spiral galaxies, the authors of the Urantia Book had presented, or predicted, exactly the sort of model that researchers have recently begun to explore. A model that assumes, or predicted, the sort of Higgs-type field both of our standard models require. In 1935. With this background in place, let's now consider the distribution and motion of energy, mass, and matter throughout the universe. In 2014, astronomer Brent Tully and his group presented a study of our local supercluster, so-called Laniakea. The novelty here is that this was not simply a plot of visible galaxies. This was their attempt to map the distribution and motion of all the energy, mass, and matter, visible and invisible, within this local region of space. For students of the Urantia Book, the remarkable thing here is that within this local region of space, the story revealed by astronomy is, at first glance, as we'll see, a surprisingly good match to the story the Urantia Book described in 1935. However, those stories begin to diverge as we expand our view out beyond the so-called KBC void. The deeper we probe into space, out beyond, say, 1 billion light-years, the more our estimates of distance depend not on actual measurements of distance, but on assumptions about redshift. Now, redshift is something that astronomers can measure most precisely, and thanks to ever-improving telescopes and techniques, we now have catalogues of redshifts for literally millions of galaxies. And, as I'm sure we all know, some of these redshifts are alarmingly big. Which brings us to a central question for cosmology: how to map these increasingly large redshifts into actual, physical, three-dimensional space. One currently popular way is to assume a simple expansion of all space in which these increasingly large redshifts imply increasingly large rates of separation. By assuming this rate of separation or expansion is directly proportional to distance, that is to say, by assuming a Hubble-type law, astronomers assume that they've solved their central problem: how to find the distance to a distant galaxy. Well, just read its redshift. So we find that nowadays most astronomers map the distribution of galaxies something like this. On the other hand, the Urantia Book implies a mapping more like this: a set of nested, concentric, counter-rotating space levels of, quote, lessened resistance to motion. Now, of course, no self-respecting, sensible, and sober cosmologist would ever dare even to suggest anything like this, a model so obviously contrived and artificial. But recall, artificial literally means made by an artist, which just happens to be the essence of Urantia Book cosmology, that the universe is a work of art. A few slides back, I mentioned that within Laniakea, that is to say, within a few 100 million light-years, both the Urantia Book and hard data from astronomy appear at first glance to reveal remarkably similar stories regarding the distribution and motion of galaxies. Let's now take a closer look at this claim. Here's a rough plot of the region within which Tully's group mapped Laniakea. Our local Virgo cluster of galaxies is near the centre. Zooming in, we find a thin sheet of galaxies, the local sheet sandwiched above and below by so-called voids, huge bubbles of relatively empty space. We are here in the middle of this sheet, within the so-called local group. Zooming in a little more, here's a map of this local sheet, about 40 million light-years across. The so-called local group with our Milky Way is here in the centre. In 2014, astronomer Marshall McCall presented a study of this region, carefully remapping all bright galaxies within 20 million light-years of the Milky Way. And this is what he found: that our local group of galaxies appears to sit just off-centre in a relatively quiescent zone, surrounded by this ring of 12 large galaxies, to which he gave the catchy name, a Council of Giants. For completeness, we should add in those halos and disks of invisible mass, segregata and ultimata, that most astronomers now assume must surround each galaxy. Also, we should indicate that local disk-shaped region, hidden from view by that, quote, dense diameter of the Milky Way. Astronomers have since found that this Council of Giants forms the inner fringe of that local sheet of galaxies, which lies within the so-called local volume, extending outwards for about 30 million light-years. This local volume appears to be centred within a second, relatively quiescent zone, the local void. The complication here is that if we assume the Milky Way lies in the same plane as that grand universe wheel described in paper 1501, then the plane of that central grand universe is not aligned with this local sheet. For students of these papers who might wonder about this, as a placeholder idea, imagine a multi-gimbal gyroscope. For stability, I like to think of the outer space levels not only rotating around the grand universe, but also precessing over, reinforcing the idea of the grand universe as a stable central kernel for the future master universe. But of course, there's no scientific or even Urantia Book justification for such speculation, so I'll just mention this issue and move on. Moving out beyond this local void, beginning from about 50 million light years beyond the outer edge of that local sheet, we find, quote, early evidence of force manifestations, the start of that distribution of mass energy mapped by Brent Tully's group, that, quote, mass-movemented, mighty-tensioned flow they call Laniakea. Okay, the story so far. Astronomy reveals that our local group of galaxies sits near the centre of a local sheet of galaxies within a local volume extending outwards for about 30 million light years. This local volume is surrounded by a relatively quiescent zone, the local void. This local void is surrounded by an expanding shell of galaxies, our local supercluster, so-called Laniakea. And beyond this expanding shell of galaxies, there's a vast, underdense zone, the KBC void, extending out to about 1 billion light years. And beyond this vast quiescent zone, astronomers are confronted by an apparent cosmic web of millions upon millions of redshifts. For students of astronomy, this is simply the story the data reveals. But for students of the Urantia Book, this story becomes something more. As we'll see, within our local supercluster, this astronomic landscape turns out to be almost exactly what the Urantia Book described in 1935. Let's take a look. The Urantia Book describes an ancient grand universe, seen here from the side, at the centre of an elliptical sheet of galaxies, again seen here from the side, extending outwards for, quote, over 25 million light years. From paper 12/114, quote, beyond the periphery of the present grand universe, we observe the beginnings of a zone of an unbelievable energy action which increases in volume and intensity for over 25 million light years. Increasing in volume and intensity for over 25 million light years. These tremendous wheels of energizing forces are situated in the first outer space level, a continuous belt of cosmic activity encircling the whole of the known, organized, and inhabited creation. End quote. Seen from above, that paragraph in paper 12 appears to be describing something like this: a continuous belt of cosmic activity encircling the whole of the known, organized, and inhabited creation. Okay, this seems straightforward. A first outer space level surrounding our place in space, radius roughly 25 million light years. On the other hand, any student of astronomy would immediately be struck by the fact that the size of this structure is, more or less, a perfect match for that local sheet astronomers have in fact found. As of 2025, this local sheet is thought to span the midplane of a local volume extending outwards for about 30 million light years. But wait, there's more. Let's zoom out a bit. From paper 12/115, quote, Still greater activities are taking place beyond these regions, for the Urantia physicists have detected early evidence of force manifestations more than 50 million light-years beyond the outermost ranges of the phenomena in the first outer space level. End quote. Now, students of astronomy would also note that this quiescent zone, 50 million light-years wide, matches that local void astronomers have also found. Also, note that reference to early evidence of force manifestations beginning about 75 million light-years away. Again, from paper 12-115, these activities undoubtedly presage the organization of the material creations of the second outer space level of the master universe. But then 3 sections later, in paper 12-4-15, we find this. Quote, "It appears that the second outer universe of galaxies, like the 7 superuniverses, revolves counterclockwise about paradise." Second outer universe of galaxies? If we assume that this second outer universe of galaxies is, say, 10 times bigger than the first outer space level, so about 250 million light-years wide, then something remarkable happens. Imagine that in cross-section, a second outer universe of galaxies looks something like this, a, quote, "zone of an unbelievable energy action, a distribution of mass energy increasing in volume and intensity for, say, 250 million light-years. Well, then this second outer universe of galaxies becomes, once again, a well-nigh perfect match for what astronomers have actually discovered. Laniakea, that expanding shell of galaxies surrounding the local sheet. Once again, here's that animated map made by Brent Tully's group back in 2014. Remember, this animation shows not the distribution of visible galaxies, but a prediction of the cosmic flow, the distribution and motion of all the energy, mass and matter within our local, expanding bubble of space. Now, clearly, there's nothing scientific about identifying Laniakea, this elliptical, donut-shaped cosmic flow, with the Urantia Book's second outer universe of galaxies. For students of the Urantia Book, this is simply an intriguing correlation. But as a student of astronomy, this remarkable correlation makes me take seriously what these papers go on to say about redshift and about the global motions of space. So let's briefly review what we know about redshift and what these papers say. As mentioned earlier, redshift is something that astronomers can measure most precisely, and the redshifts of galaxies in Laniakea reveal a very clear pattern. For example, galaxies in clusters near the outer edge all share similar redshifts, about 0.016. For small redshifts like this, astronomers often refer to radial velocity rather than redshift. So we find that galaxies near the outer edge of this donut-shaped volume of space are all receding at about 4,500 kilometers per second. Now, as also mentioned earlier, within this local region of space, astronomers have a number of techniques for estimating distance. They use these to calibrate so-called distance ladders, which they then use for mapping distances to galaxies. When these distances are plotted against velocities, that famous relationship between distance and velocity becomes clear. What we have here is compelling confirmation of a so-called Hubble flow. But notice what this data actually confirms is a local Hubble flow. Hold that thought. Meanwhile, cosmologists discovered a background of microwave radiation, their smoking gun confirmation of some Big Bang. Against this background, students of cosmology are now more or less compelled to conclude, what more proof do we need? Galaxies racing away, a microwave background, a model that mostly works? why waste time inventing and exploring alternatives? Well, pause to consider. In 1935, in paper 1164, the Urantia Book revealed that for almost 500 million years, space has in fact been expanding. In other words, according to the Urantia Book, any galaxy within 300 million light-years, that is to say, every galaxy in this second outer universe of galaxies, has in fact been receding for over 300 million years. Exactly what astronomers have found. A local, Hubble-like outwards flow. However, while cosmologists then extrapolate a global Hubble flow and runaway expansion, the Urantia Book describes the very opposite, a gentle 2 billion-year cycle of expansion and contraction, and a universe far older than 14 billion years. Thus, students of the Urantia Book are very keen to explore alternatives. So we find that, at least within this local bubble of space, redshift and standard candles work well to confirm a local Hubble flow. But as we move out into deep space, things become less clear. As we saw earlier, this second outer universe of galaxies is surrounded by another quiescent zone, the so-called KBC void, or local hole. This region appears to extend about 500 to 700 million light-years beyond Laniakea, so out to about 1 billion light-years. Once again, this zone is not empty of galaxies, it's just a region where the density of galaxies is noticeably reduced. And beyond this void? Well, beyond 1 billion light-years, native science is confronted by that apparent cosmic web. Which brings us back to that crucial point. The further astronomers probe beyond this third quiescent zone, the more their estimates of distance depend not on actual measurements of distance, but on assumptions about redshift. Here, let's recall that central problem of cosmology, how to map ever-increasing redshifts into physical, three-dimensional space. A lot of time and money, and many careers, have been spent on this question, and for a number of decades, so-called lambda CDM has been considered an excellent answer, given what the scientific method has been able to reveal. In this model, for redshifts from beyond the KBC void, a Hubble-Lemaitre type law is thought to apply. So cosmologists map redshifts in the simplest possible way. Essentially, inflation followed by an accelerated expansion, everything unfolding in less than 14 billion years. Using this idea of an expanding, big-banged universe, cosmologists found that they could explain most things that astronomers have found. For example, imagine a galaxy with redshift of 0.16. Using this standard model, a redshift of 0.16 implies that this galaxy must be about 2.2 billion light-years away and be receding at about 30,000 miles a second. And until recently, everything was good. But then astronomers began to find things like this, apparently mature galaxies with redshifts of 14. Now, in current consensus models, a galaxy with a redshift of 14 must be less than 1 billion years old, be over 30 billion light-years away, and be receding at more than twice the speed of light. Of course, by adjusting some assumptions about galaxy formation, cosmologists can make such data fit. But their models are being stretched, and certain tensions have appeared, which reminds one of the old saying, cosmologists are always wrong, but never in doubt. So, what does the Urantia Book say about redshifts, this shifting of spectral lines? Well, for small displacements, the papers simply confirm our current ideas. But with regard to the large redshifts of galaxies in deep space, These papers say something truly unexpected. Let's take a look. Imagine that galaxy with redshift of 0.16 receding at 30,000 miles a second. Referring to our use of a Hubble-type law to estimate distance and velocity, the Urantia Book throws a spanner in the works. From paragraph 12.4.14, quote, "By this method of reckoning, it will appear that these far-distant systems are in flight from this part of the universe at the unbelievable rate of more than 30,000 miles a second. But this apparent speed of recession is not real." End quote. Not real? Well, one has to ask, if this apparent speed of recession is not real, then what's causing this enormous redshifting, or distortion, of spectral lines? Which brings us to paragraph 12.4.15, and that unexpected idea, quote, "But the greatest of all such distortions arises because the vast universes of outer space seem to be revolving." Here, the authors appear to be saying that the greatest cause of the enormous redshifts of galaxies in deep space is due to sideways, not radial, velocities. So what if a galaxy 2 billion light-years away were moving sideways directly across our line of sight at, say, half the speed of light? Well, as we'll see, once again, we'd measure a redshift of 0.16. Okay, first question. If a galaxy were moving sideways across our line of sight at half the speed of light, surely astronomers would have noticed. Well, let's pause to consider. Say that galaxy, 2 billion light-years away, is about the size of our Milky Way, so about 100,000 light-years across. This means it would take light, travelling at the speed of light, 100,000 years to cross that galaxy. Now, imagine that in some telescope, the image of that galaxy is about 100 pixels wide. Then, if that galaxy were moving sideways directly across our line of sight at half the speed of light, it would take 2,000 years for the image in that telescope to shift by 1 pixel. The point being that for the foreseeable future, this kind of direct measurement of transverse velocity will remain a challenge. However, as I'll explain in a moment, a pair of upcoming survey missions may just solve this problem and help to prove relativistic sideways motion in outer space. Okay, next question. But how can sideways motion cause redshift? To see how this can work, we need to review that strange idea about light and time. Imagine a spaceship with a light clock ticking away. Each cycle of a photon up and down measures one local tick of this clock. The astronauts on that spaceship use this light clock to measure the passing of time. Now, imagine this spaceship zooming by directly across our line of sight. From our point of view, we measure the length of that photon's path to be longer than the path measured locally by those on a spaceship. So, if the speed of light is the same for all observers, as Einstein proposed, then we'd measure the light clock on that spaceship to be ticking slow. 100 years of study apparently confirms that this effect is real. If we assume that it is, let's think what this means. Imagine that spaceship zooming directly across our line of sight. As it turns out, this particular type of spaceship has a tail light that flashes blue light with a wavelength of 450 nanometers. Now, some scientist with a telescope is asked to estimate the spaceship speed. He observes the tail light flash and measures a wavelength of 660 nanometers. In other words, he sees this blue tail light flashing red. Now, this scientist happens to know a thing or two about relative motion, and running the numbers, he finds a Lorentz factor, gamma, of 1.47. After a little algebra, he reports that this spaceship is zooming by at 73% the speed of light. Okay, that's the situation for a spaceship zooming sideways directly across our line of sight. Now, imagine a second spaceship with the same type of flashing blue light, but this ship is zooming away directly along our line of sight. Once again, a scientist with a telescope is asked to work out how fast this ship is moving away. When he observes that blue tail light, he also sees it flashing red. As it turns out, this scientist happens to know a thing or two about the Doppler shifting of light. Running the numbers, he finds a redshift of 0.467 and reports that this spaceship is receding at just over 46% the speed of light. Which brings us to a curious issue. If a spaceship with one of those flashing blue tail lights is cruising deep in outer space, and we take a snapshot with our best telescope and measure that blue light to be flashing red, is this redshift due to radial or transverse motion? In other words, is that ship receding along our line of sight at 46% the speed of light, or is it zooming across our line of sight at 73% light speed? This issue becomes more interesting if we replace that spaceship with a galaxy. Let's say we know from astrophysics that if this galaxy were not moving relative to us, then a certain spectral line will be found at a wavelength of 300 nanometers. But when we observe that galaxy with our best telescope, we measure that spectral line at 348 nanometers. In other words, we observe a redshift of 0.16. As we've just seen, this redshifting of spectral lines can certainly be caused by radial motion directly along our line of sight. But it can also be caused by transverse motion directly across our line of sight. So which is it? Is that galaxy receding at that, quote, unbelievable rate of more than 30,000 miles a second? Or is it zooming sideways at half the speed of light? But the plot, she thickens. In October 2023 and January 2024, the James Webb Space Telescope observed a galaxy with redshift of 14.1. This means that a spectral line emitted or absorbed by that galaxy at 300 nanometers would be measured by the telescope at 4,500 nanometers, or 4.5 microns. Now, using lambda CDM, a cosmologist would conclude that this galaxy must be over 30 billion light-years away and be receding at more than twice the speed of light. On the other hand, if that galaxy were moving directly across our line of sight at just under the speed of light, we would also observe a redshift of 14.1. So once again, which is it? Is this galaxy receding at over twice the speed of light? Or is it cruising sideways at just under unit velocity, the local speed of light? Regarding unit velocity, recall that midwayers can move twice this fast, while seraphim can reach 3 times this speed. Point being that on a cosmic scale, the local speed of light becomes literally painfully slow. Let's now try to see what all this means for motion in the outer space levels, those curved space paths of lessened resistance to motion. Regarding the first outer space level, The relatively tiny velocities and redshifts are due both to the current expansion phase of space respiration and local gravitational interactions. Likewise in Laniakea, the second outer space level. Since all these galaxies lie within 300 million light-years, the most recent 500 million years of expansion imposes that characteristic local Hubble flow. But moving out beyond that KBC void, things become more interesting. From paper 1178, quote, "A space level thus functions as an elliptical region of motion, surrounded on all sides by relative motionlessness." End quote. This appears to imply that at its inner and outer margins, a space level is relatively motionless. So in this third outer space level, we'd expect little or no sideways motion at the edges, rising to some maximum sideways flow midstream. Likewise, in the fourth outer space level, once again, we'd expect little or no sideways motion at the inner and outer edges, with the rate of flow rising to some maximum speed midstream. In this case, if we assume the rate of this midstream flow approaches the local speed of light, or unit velocity, then this model easily accommodates redshifts well beyond 14, all the while bounding the actual velocity of galaxies below the speed of light. So, with these details in place, when we put all this together, we get the Urantia Book's model of the absolute motion of space itself, so-called space respiration, and those counter-rotating levels of outer space. Now, if we simply allow the midstream flows of the third and fourth outer space levels to be relativistic, then, as we've seen, this model can accommodate any redshift any astronomer might ever observe. So now, let's ask the question, is there any possible way to prove this unorthodox idea that the primary cause of cosmological redshift is relativistic sideways flow, and not some runaway expansion? As it turns out, there may just be. The Rubin Observatory is about to begin its 10-year survey of space and time. One of its 4 main goals is to identify things that unexpectedly change. And one thing that would certainly cause an unexpected change is if a massive galaxy in the third outer space level happens to gravitationally lens a quasar in the fourth outer space level, moving sideways at near the speed of light. But even better, in 2027, the Roman Space Telescope will begin a more focused and fine-tuned survey of things that change. For a quasar moving sideways, nano-lensed by a foreground massive galaxy, this next-gen space telescope will be able to snap frames of a movie that, within a year, could prove the transverse or sideways motion of the most distant objects in space. While not confirming a Urantia Book cosmology, it would certainly compel cosmologists to pause to consider. So what if astronomers did see something like this, hard evidence of a quasar or little red dot moving sideways? Well, for the next 10 years, scientists would propose events and epicycles to explain such things away. Well, thanks for listening to all that. Let's wrap up by collecting a few final thoughts. As I'm sure we'd all agree, it's a long way from detecting a quasar moving sideways to discovering a cosmos of nested counter-rotating levels of outer space and cycles of space respiration. So, where do things stand? Clearly, the enormous redshifts of galaxies in deep space can be explained by an accelerating runaway expansion, as proposed in current Big Bang models. But as we've seen, such redshifts can also be explained by relativistic rotation. We've also seen that the first outer space level, as described in the Urantia Book, is a remarkably good match to the so-called local sheet astronomers have found. And we've also seen that the Urantia Book's, quote, second outer universe of galaxies can easily be identified with Laniakea, our local supercluster, surrounded by that enormous KBC void. So here's the challenge. The Urantia Book reveals a cosmology that's far beyond the reach of either scientific discovery or religious experience. Thus, exploring this model will require an approach that involves philosophy and faith. At the same time, we must keep in mind that astronomy and cosmology, the study of how the heavens go, is a matter of science, not faith. So we need to approach this study not as evangelists, but as students exploring an idea. Okay, that's my attempt to explore that unexpected line in paragraph 12.4.15, that hint about a connection between redshift and rotation. Quote, "But the greatest of all such distortions arises because the vast universes of outer space seem to be revolving." Clearly, a cosmology that involves an ancient, central, grand universe wheel surrounded by nested, counter-rotating levels of outer space implies many interesting things.
So it looks like Jeff, right off the bat, has a question.
So, Nigel, distances up to Laniakea are okay, with Z's of 0.16. But beyond that, our current measurements are flawed and really shouldn't be used, right? So we need some sort of correction factor beyond the 300 million light years out. But that's additive to the rotation correction. So it strikes me that we're rotating. First outer space level is rotating. Second outer space level is rotating. Are those rotations and counter rotations not additive to the Z error? In other words, instead of almost the speed of light, this one and this one, we could have some gravitational lensing from each layer. And the other thing is we're really looking at both translation and recession as contributions to the redshift. It's not an either or situation. It's a both situation. And the third point is, can we not look at visible light and radio wave X-ray at the different redshifts or the different Doppler shifts really in each of those frequencies and see how they relate to distance? Does that not give us some additional information on this?
Right, well, I'll try to sneak into that set of questions. The first and most important thing is that within 300 million light years, within its Laniakea supercluster, the redshifts are tiny. So the rotation doesn't really factor into it. I do mention that until you get out to beyond the KBC void, then it's mostly gravitational interaction and this expansion of the last, this current phase of space respiration. So that is more significant than the very rather slow rate of rotation in the first and second outer space levels. The thing to note there is that relative to what I'm, suggesting are the third and fourth outer space levels, the first two are, cosmologically speaking, tiny. You might remember that in the current sort of cosmological web type model, the idea of homogeneous and isotropic, they're using Laniakea effectively as the cell, the unit in the cosmic web. Because we've got nothing else to go on, we've mapped out this local supercluster very well, and if you copy and paste that throughout the, throughout the universe, then you get this cosmic web. Now, the assumption of homogeneity and isotropy, the what's that called? It's the cosmological principle that the universe is the same everywhere and in all directions. Well, it's interesting to note that Laniakea has become effectively the particle of the cosmic web. And that's just an assumption. So they built assumptions upon assumptions upon assumptions. And what I'm suggesting here is that we can, astronomy and the Urantia book fit quite nicely together within this sort of this region that's currently expanding because it's a very consistent Hubble flow. If we're thinking about the last 500 million years of space respiration, where it's been in this lovely, smooth, sinusoidal expansion. So that matches exactly what we've seen out to about, 300 million light years, 100 megaparsecs. So the question that you're actually asking there is, why is Redshift wholly unreliable? And that's the first of my appendices. And it's unreliable. We'll leave that till we get to the appendix, because it's unreliable in two very, very different ways. And my diagrams in the first appendix should make that clear. Was there anything else? There were quite a lot of questions you had there. Anything else before we move on?
I have a bunch of questions, but I'll talk to you later on.
Right.
I won't take anybody
Just
else's
keep
time.
them in mind. Oh, and also,
Yeah.
if you notice anything which is inconsistent, see, all of this speculation is my attempt to use the exact Urantia book text and overlay it onto what we can verify with astronomy. So, it's all a lot of hand waving at this stage, but it fits so nicely that I'm prepared to, stick my neck out and run with this. So let's have another question. Thanks, Jeff.
Okay, I'm going to ask Halbert's question because it has to do with Phil, whose hand is up. So I think this may basically kill two birds with one stone here. It says, Halbert is asking, I remember that Phil Calabrese did a presentation to work out the math related to the rotations. How much does his work complement your own? And Phil, if you want to weigh in with something for Nigel that's relevant to that, or if you can hold your question, what would you like to do?
Well, I think I know the answer to that. I've listened to Nigel's presentation twice, and yeah, I've got something different to say. When I did that, I wasn't considering any kind of relativity kind of phenomena that might be involved. Although the observation I had was when I did uh, the Doppler calculation of particles moving radially away, what I found was that why is there a redshift? Well, it's because the particles aren't emitted instantaneously. They are emitted over time, so that the wavelength gets stretched out as you go radially. Well, it turns out that the wavelength gets stretched out when you go radially too. So I guess I'm getting with Nigel on that to say that I can see how radial motion, where the particle takes some time to be emitted, just like in the when the particle moves away from the observer, the reason why the wavelength gets redder is because it takes some time for each particle to be emitted. And each time that happens, it's further away. So as it goes, it stretches out the wave. Well, it also stretches out the wave when it's only going radially, which is a realization that I've come to as I've been listening to Nigel's talk. So that very well means that he's identified how time, or at least the frequency, can be, reduced through radial motion. So I guess I just want to make that comment that I'm now. I guess I can see how that happens from a basic emission idea of particles from a radially moving object.
Okay, we have kind of a simplistic question from one of our audience members, who is Rick Warren, and he's this is probably going to be controversy here. Is the Andromeda Galaxy in the first outer space level or the super universe ring?
I cover that in great depth in the previous video on YouTube. So if you can
Right.
track down my cosmology playlist, part 4D, Ancient Orvonton and a Young Cosmic Web, that sketches out my current best thoughts about that particular question.
Andre, we're going to let you take a few minutes, and then we're going to go to Nigel's pre-recorded questions and answers.
Okay. Well, you referred to, I think, to 12.4.15 a few times. There's this curious thing as well. You referred to the second outer space level, but then when it talks about, it makes this final statement, and the astronomical observers of Uversa think they detect evidence of revolutionary movements in a third outer belt of far distant space, which are beginning to exhibit directional tendencies of a clockwise nature. There's this implication that there's almost nothing of really significant materialization in the third outer space level. Otherwise, you would think that the Uversa astronomers would do more than think that they observe things in that region. And so you're obviously aware of Bill Sadler Jr.'s geometric speculations and how he came to the idea of the increase of 25 million years, light years rather, implying a decrease of 25 million light years in the one space level. And then, it's fairly arbitrary what he came up with, this 100 times factor. I like the fact that you're matching things up. But on the other hand, how do you explain that in our space level, we seem to have that same kind of thing going on, where there's an increase for 250,000 light years and a decrease of 250,000 light years to where we are when you span the transverse diameter of the superuniverse space level? Would you not expect things to match somewhat in the outer space levels that way, or what's your thinking?
That's actually addressed in Appendix
I haven't
5.
seen your most recent videos, by the way. I went through all of them maybe a year and a half or 2 years ago, but I'll bet I've missed a few since then.
Okay, so is it going to be in one of them that you're going to play for us now, Nigel? Is that?
Yeah.
Okay.
Yeah.
Well, then
Okay.
let me let David ask his question, and then we'll go and let you play your.
And Phil's got his hand up too.
Yeah,
I
it
think
feels
we'll
good.
go to
I just
Phil
want to
because
say that I think I misspoke, that I meant that I now see how redshift can happen with axial rotation rather than radial.
Transverse.
Yeah,
Yeah.
right. That's what I meant to say. I see that because it takes time in either case for the particle to be emitted. And so if the distance is made a little more by axial, that will cause redshift too. So I didn't say it clearly last time. Thank you.
Okay. We appreciate it. Okay, David, go David.
let's see. Okay, well, I was thinking about the bell curve and how well exactly what Andre was saying. Uh, if you're going inward toward the central universe, you'll have an increase of material activity, and if you're going the other way, you have an increase in activity until you get to what I would think of as a kernel, and then it would drop off again. They don't mention it, but they don't mention a lot of things. They make patterns for us to see. So, because I just couldn't imagine it goes out and increases for 250,000 light years and then just drops off as a sudden void and there's nothing else until you get to the next thing that they talk about. So I'm thinking more that would be a more of a bell curve shape instead of that sudden drop off. So you would have a 50 million light year first outer space level.
All right. So Nigel, are you going
And maybe
to
just one other thing. If you could keep in mind where they talk about our measurement of distances are wholly unreliable in the, outside of the super universe space level. That's all I need to say. If you could answer that at some point.
That's Appendix 1. Let me share my screen. I do that. Right. So this is a couple of, these are some questions that I think all of us are interested in. Why is redshift wholly unreliable? Any evidence for space respiration? Do the papers confirm or deny this idea of dark matter? What about the famous Higgs-type field? I mentioned that, it's technical, but the point is that all of our current standard model of physics and cosmology is built on what we call a condensative weak hypercharge, a Higgs-type field. So we're going to have to address that at some point. Now, this is where we get to Dave and Andre. Dave, and you were talking about the bell curve and the shape. Is it going to go increase and then decrease in some symmetrical way? What we need to add to that discussion is the tidal effects of the phenomena at the center. So we've got, if we're going to have a curved universe, an elliptical universe, then think of paradise as imposing a global curvature on the whole thing, the whole master universe. And this then is what I'll be talking about in Appendix 5. And finally, for a bit of fun, where exactly did paradise bestow space, given that space is a bestowal of paradise? All right, so look, here's the, and these are the appendices. So if we could now play that second movie. Appendix 1, wholly unreliable. In paper 12, section 4, the authors imply two very different cases where using redshift to determine velocity becomes, quote, wholly unreliable. The first case applies locally within the first outer space level. Think of all those relative motions, all those rotating wheels within wheels, minor sectors rotating within major sectors orbiting Uversa, superuniverses orbiting Havona, the first outer space level rotating around the grand universe wheel. The relative Doppler shifts due to all these local relative motions conspire to make any estimate of absolute velocity impossible. Also, note that within Laniakea, within our local bubble of expanding space, all these relative velocities and Doppler shifts are, relatively speaking, tiny. The second case, where using redshift to determine velocity becomes wholly unreliable, involves the enormous redshifts of galaxies that lie beyond the KBC void. By assuming that a Hubble-type law still applies to these truly distant galaxies, astronomers are led to assume that they can estimate their distance and velocity simply by reading their redshift. However, the author of paper 12.4.15 claims this use of redshift is wholly unreliable because most of the redshift is caused not by radial velocity due to a runaway expansion, but by transverse motion along the geodesics of curved space paths. Here, it's important to note that any light we observe from such distant galaxies was emitted perpendicular to the velocity of that galaxy. Hence, its redshift is not affected by any Doppler shift, being due entirely to the time dilation of special relativity. Appendix 2. Space Respiration. Regarding current assumptions about space, I'm sure we all know this story that cosmologists currently like to tell, which goes something like this. Given one miracle, one miraculous moment of cosmic inflation, and two little assumptions, we can predict that the universe began to expand about 13.8 billion years ago. Nowadays, these two little assumptions about redshift and rate of expansion seem so obviously true that some cosmologists no longer see them as assumptions, but rather as hard facts which their models must obey. It's no exaggeration to say that this story, this proposed expansion history of the universe, sits on these two assumptions. So in 2015, two physicists, not cosmologists, Harry Ringemacher and Lawrence Mead, took a close look at these assumptions and this story and the best data of the day. And they noticed something subtle in the supernova data, that the rate of change of the expansion has been changing every 2 billion years or so. They proposed that a simple Big Banged universe was in some sense ringing or oscillating as it expanded, that over the last 13 or 14 billion years, the rate of expansion of the universe has sped up and slowed down 6 or 7 times. The Urantia Book takes this unorthodox idea one more step. It proposes cycles 2 billion years long of gentle oscillation, of so-called space respiration. Paper 11, Section 6, discusses the idea. Appendix 3. Ultimatonic WIMPs and a quantum of curvature. In the late 1970s, when Vera Rubin first noticed those famous flat rotation curves of spiral galaxies, scientists were faced with a problem. Either our ideas about gravity would need to be modified, or most of the mass of the universe must be invisible or dark. In the 1980s, scientists began to discuss the so-called WIMP miracle. The idea was that if spiral galaxies were embedded in some vast halo of invisible, weakly interacting massive particles, or WIMPs, this would help to explain why spiral galaxies rotate the way they do. In 1935, the Urantia Book predicted something similar. A primary force organizer condenses a halo of segregata, within which an associate force organizer spins up a disk of ultimata. Then, within such vast dark disks, atoms and stars begin to form, and eventually, spirals of stars. In this scenario, the ultimaton becomes quite literally the ultimate WIMP. It's weakly interacting because it interacts only via the weak force, and it's massive not in the sense of lots of mass, but as the fundamental unit or quantum of gravitational response. Which brings us to a second, very different WIMP miracle. In paper 42, section 6, an absolute relationship between ultimatons and paradise is described. From 42.6.3, quote, Automatons functioned by mutual attraction, responding only to the circular paradise gravity pull. Given this direct, absolute relationship, we can make a case for automatons being some quantity of space potency, or absoluta, with all the space squeezed out. If so, then the density of an automaton would make it a quantum of curvature, the sort of curvature faintly glimpsed by Einstein. In other words, a quantum of classical gravity. Now, if we think of so-called absolute or paradise gravity as the curvature imposed by paradise acting on space, then the automaton, the quantum of that curvature, becomes a quantum of absolute gravity, the quantum of material response to paradise. Which leads to an interesting idea. Imagine the density of automatons causing local gradients in space, such that neighboring co-moving automatons might tend to fall together, that mutual attraction mentioned in 42.6.3. Mathematically, we'd have a balance of forces, that mutual attraction drawing a few automatons together, while some extreme repulsion from their quantum of automatonic spin, Planck's quantum of action, keeps them apart. This sort of balance between mutual attraction and extreme repulsion might help to explain that, quote, unexplained proclivity of automatons to huddle. Given all this, we might even model the so-called weak or short-range interaction of standard model physics as the action of absolute gravity acting at the smallest so-called Planck scale on those automatonic WIMPs. Which brings us to a third WIMP miracle. Given such tiny clusters of huddling automatonic WIMPs, we can make contact with standard model physics in the following way. 1. Build up the Dirac electron from a superposition of pairs of Weyl spinners. 2. Build these spinners from smaller parts designed and tuned to interact with that Higgs-type field. And 3. Build these interactive parts from Planck-scale things, our huddling automatons. We can use the same sort of scheme for all leptons and quarks. And, as one might expect, accounting for all these internal spinning parts might even allow us to predict those so-called coupling constants for all standard model particles, something that all physicists are very keen to do. Oh, and one more thing. Given that Frank Wilczek's axion was invented to help clean up a problem in the standard model for particles, it's tempting to describe the automaton as an axionic WIMP. Appendix 4. Segregator, Higgs, and the local speed of light. Two current assumptions in cosmology are 1. That space is pervaded by a field of primitive weak hypercharge, that so-called Higgs-type field, and 2. That this field has a vacuum expectation value, or VEV, that's everywhere the same. Another assumption is that empty space has a certain electrical permittivity and magnetic permeability that, once again, are everywhere the same. Using these locally measured values, scientists then define a speed of light in empty space like so. By 1970, a connection between electromagnetic and weak interactions had been proposed such that electric charge can be defined in terms of weak isospin and weak hypercharge. This deep connection between that short-range ultramatonic force, see Appendix 3, and standard quantum electrodynamics, or QED, implies something interesting about the way electromagnetic light moves through that field or condensate of primitive weak hypercharge. In 1935, the Urantia Book also predicted a condensate of primitive charge, so-called primordial force charge, or segregator. But this was different to our standard model Higgs-type field. In particular, its distribution or vacuum expectation value was not everywhere the same. This Urantia Book version of a Higgs-type field was locally localized, appearing only where some organizer of force acted to condense so-called space potency or absoluta, which raises the question, if the vacuum expectation value of a Higgs-type field affects in some way the permittivity and permeability of space, and if we identify the Standard Model's condensate of weak hypercharge with the Urantia Book's segregata, then any variation in the distribution of segregata would imply variation in the local permittivity and permeability of space, hence variation in the local speed of light. In particular, the speed of light within a galaxy would be different to the speed of light between galaxies. Appendix 5. Ricci and Weyl curvature. The components in the Riemann tensor of Einstein's equations mediate two very different effects. One effect is so-called Ricci curvature, which mediates the contraction of a spherical or circular distribution of mass energy. The other is so-called Weyl curvature, which mediates torsion and tidal effects. Of interest here is that if a spherical or circular distribution is orbiting some gravitating center, like a superuniverse orbiting Paradise Havona, then the effect of Weyl curvature is to preserve the volume while extruding that distribution into a flattened almond shape. Some implications of this feature of Einstein's, quote, faintly glimpsed findings feature from time 1832 in the previous YouTube video, part 4D. Appendix 6. The bestowal of space. Space, as presented in the Urantia Book, is very different to the old idea of a 3D Newtonian now, or the simple 4D fabric faintly glimpsed by Einstein. In the Urantia Book, space is, quote, a bestowal of paradise, which raises the question, where exactly did paradise bestow that space? Let's take a look. In some non-time sequence of events, the I am qualifies a center. This center, paradise, becomes a base of operations for personality. Note, at this stage, space does not exist. In paper 1129, this center, paradise, is said to be made of a homogeneous organization of space potency, so-called absolutum. Then, in that non-time sequence of events, a differential, locally localized melting and inflation of this absolutum allows spaces of absoluta, or space potency, to appear, like chambers in a heart. These chambers, these spatial excavations, counterbalance and start to move. This cosmic heart begins to beat, and the master universe age begins. So, what happens next? In paper 10678, the authors explain that after this master universe age, when this entire master universe is perfected and complete, its entire history will appear to be, quote, only a beginning. Simply the creation of certain finite and transcendental foundations for even greater and more enthralling metamorphoses in uncharted infinity. At such a future eternity moment, not only will the master universe still seem young, but the purpose and seven-dimensional destiny of finalitas will become clear.
Well done.
Thank you for putting up with all of that. That
Very
was a
nice.
lot of fun to put together, light-hearted, but hopefully enjoyable and scientifically based.
What's your like
So,
thought process? How do you do this? I mean, are you like constantly researching the science, and then I know your heart is in the Urantia book, and then the science is like applied somehow. But how do you answer that?
The trick is to avoid complications like cars, girlfriends, and houses.
Oh,
oh,
there you go.
okay. There you go.
That's been
When
my
you
methodology too.
when you simplify things, well, you've got more time.
So
Okay.
when you if you subtract the radial motion that is erroneous, do you get space respiration? Do you get a periodic motion such as 2 billion year periodic motion?
As Halbert once said to me, once you allow for both radial space respiration and rotation, then it becomes almost impossible to make sense of anything, out beyond a billion light years. So we really are floundering.
All right.
Okay, we are totally out of time. So thank you very much, and we'll end on that note with the thanks to our Father, our Universal Mother Spirit, and our Creator Brother Jesus. Thank you.